Welcome to the Introduction to Programming playlist. So the overall goal of this channel when it comes to programming is to become well-versed in all of the programming languages that are commonly used by scientists and engineers. So Python, MATLAB, C, C++, Java. So not to become a professional computer scientist or to gain professional licensure for using these programming languages, but to become as much of an expert as any scientist or engineer who would use one of these programming languages in their field. And this playlist is the general introduction, overall introduction to programming. So if you have no experience in programming, or if you perhaps know some MATLAB or Python pretty well, but overall you would like to start on the road to understanding the full scope of programming and all of the main programming languages, this is where you want to start. But actually, we're going to see in a second that this particular playlist, so this textbook that we'll be covering, is actually aimed at both computer science and non-computer science majors. So actually, a computer science major could watch this particular playlist and go through this textbook as well, if desired. And so, okay, the textbook that we're going to be going through in this playlist is Introduction to Computation and Programming Using Python, with Application to Understanding Data by John Guttag. And so this textbook isn't an official introduction to Python. It's more of an introductory overview of computation and programming in general using Python. But we're still going to learn a lot about how to program with Python in this course. Okay, so this textbook has 24 chapters, which we could separate into two parts. So chapters 1 to 11 is one part, and then chapters 12 to 24 is the second part. So in chapters 1 through 11, we learn about programming. These chapters are aimed at students with little or no programming experience. So part of learning how to program is figuring out what objects to create. How do you represent knowledge with data structures? So part of learning how to program is figuring out what objects to create. How do you represent knowledge with data structures? Okay, now programs aren't just linear, but they jump around and make decisions. So there's some control flow to programs. Okay, so iteration and recursion in programming. Iteration meaning repeating a set of instructions. Recursion meaning kind of like a recursive formula in algebra, but from a programming perspective. You're breaking down a problem into smaller subproblems. Okay, abstraction of procedures and data types, as well as organizing and modularizing systems using object classes and methods. So how do you write good code, good style, code that's readable and understandable? Modular. Code needs to be read by other people. All right, so abstraction in programming is the process of simplifying complex systems by hiding unnecessary details and showing only the essential features to the user or other parts of the system. Modularization means you're breaking up a large, complex program into smaller, independent pieces called modules, each performing a distinct, well-defined function. Okay, also in chapters 1 through 11, the beginning is more about programming, but towards the end is more about computer science. So how do you compare programs in Python? How do you know if one program is better or more efficient than another? Okay, now part 2, chapters 12 to 24, is less about programming and more about data science. So data science being the science of analyzing and extracting information from large sets of data. So you've got these large sets of data, and you're going to use programming to extract data and apply statistics, math, etc., and come up with conclusions, make predictions, make models. So we'll talk about some software engineering. We'll talk about how to structure your code. There'll be more emphasis on using packages with programming. So not the fine details of programming, but packages. Okay, but the main topic of chapters 12 to 24 is computational models. So how do we use computation to understand the world in which we live? Science is moving out of the pure natural laboratory and into the computer. So experimentation is and always will be important, but experimentation now needs to be supplemented by computation. Okay, so this book is based on courses that have been offered at MIT since 2006 and as massive online open courses through EDX and MITx since 2012. So yeah, this textbook corresponds to an MIT course, and in particular an MIT course that's posted on the MIT Open Courseware website. So I'll post links in the description to these. There's two separate courses. One goes through part 1, chapters 1 to 11, and the other goes through part 2, chapters 12 to 24. So if you want, you could also take a look at those lectures as well, those lecture videos. Okay, the first edition of the book was based on, this is the second edition we're going through, was based on a single one-semester course. However, over time, I couldn't resist adding, this is John Guttag writing this, more material than could be fit into a semester. The current edition is suitable for a 2-semester introductory computer science sequence. When I started working on the second edition, I thought that I would just add a few chapters, but I ended up doing far more. I reorganized the back half of the book and converted the entire book from Python 2 to Python 3. The book is aimed at students with little or no programming experience who have a desire to understand computational approaches to problem solving. For some of the students, the material in this book will be a stepping stone to more advanced computer science courses, but for many of the students, it will be their only formal exposure to computer science. So yeah, you can see here that this particular textbook, this particular course, is applicable to both computer science and non-computer science majors. Okay, but now this channel is not designed for computer science majors. It's more of an engineering channel. And when it comes to programming, the programming playlists are more catered to engineers and scientists who don't want to become professional programmers, but more of expert programmers in terms of applying programming in their fields. And so these would fall under this category, students to where this textbook, this course will be their only formal exposure to computer science. So what we're doing in this textbook is, again, for more engineers and scientists, we're using this as an overview of computer science and programming, to where then by the end of this course, we can take this and use it as a foundation to go straight into learning the main programming languages. So Python, MATLAB, we're going to get a really good introduction to Python in this course, but there'll be other playlists where we'll go more officially, more systematically through Python and MATLAB, C++, Java. Whereas if you're a computer science major, you can take this course, go through this playlist, but then after this playlist, you would advance to more dedicated computer science courses. Okay, because this will be the only formal exposure to computer science for many of the students, we emphasize breadth rather than depth. The goal is to provide students with a brief introduction to many topics so that they will have an idea of what's possible when the time comes to think about how to use computation to accomplish a goal. That said, this is not a computation appreciation book. It is challenging and rigorous. Students who wish to really learn the material will have to spend a lot of time and effort learning to bend the computer to their will. Yeah, exactly. This is perfect. Perfect for engineering and science majors. Because we don't want to just read some computation appreciation book like we're watching a 2-hour documentary on PBS. No, this is a substantial, rigorous introduction to computation and programming. An overview, a broad overview of computer science. But again, it's not just some story we're reading like we're watching a show, a 2-hour show. No, I mean, we're really going to get into it. So again, we'll learn not to become professionals, but to become engineering and science experts in the different programming languages, the main programming languages that engineers and scientists use, but this course is going to serve as the foundation, the computer science foundation of your ability to program. The main goal of this book is to help students become skillful at making productive use of computational techniques. They should learn to use computational modes of thoughts to frame problems and to guide the process of extracting information from data. The primary knowledge they will take away from this book is the art of computational problem solving. This book is not easily slotted into a conventional computer science curriculum. Chapters 1 to 11 contain the kind of material typically included in a computer science course aimed at students with little or no programming experience. Okay, so just FYI, if you're not familiar, computer science is the study of computers and computational systems, focusing on the theory, design, development, and application of software and hardware. Okay? Chapters 12 to 24 contain slightly more advanced material, various subsets of which could be added to the introductory course if the students are more advanced. Yeah, so what they're talking about is this entire textbook is separated into 2 courses, which again, I'm going to post the links to these courses on the OpenCourseWare site, MIT OpenCourseWare site in the description. And so they're just talking about how would you divide up the chapters between the 2 courses, the 2 semesters. Chapters 15 to 24 are about using computation to help understand data. They cover the material that we think should become the usual second course in a computer science curriculum, replacing the traditional data structures course. Right, but again, what's nice though is the way this course in this textbook is designed is it's more of an overview. It's also designed for non-computer science majors, to where this is going to be their only formal exposure to computer science, right? Okay, in chapters 1 through 11, we braid together 4 strands of material: the basics of programming, the Python 3 programming language, computational problem-solving techniques, computational complexity, and using plots to present information. Okay, so computational complexity being the study of the computing resources like time and memory that are needed to solve a problem, in particular as the size of the input grows. Okay, we cover most of Python's features, but the emphasis is on what one can do with a programming language, not on the language itself. For example, by the end of chapter 3, the book has covered only a small fraction of Python, but it has already introduced the notions of exhaustive enumeration, guess and check algorithms, bisection search, and efficient approximation algorithms. Right, so this textbook isn't about Python. This is not an introduction to Python. We are going to get a solid introduction to Python in the process, but like they're saying, this is really more about what one can do with a programming language, not on the language itself. But we're going to learn about what one can do with a programming language. And as we learn about computation in computer science, we're going to use Python. We introduce features of Python throughout the book. Similarly, we introduce aspects of programming methods throughout the book. The idea is to help students learn Python and how to be a good programmer in the context of using computation to solve interesting problems. The examples in this book have been tested using Python 3.5. Python 3 cleaned up many of the inconsistencies in the design of the various releases of Python 2, often referred to as Python 2.x. However, it is not backward compatible. That meant that most programs written using Python 2 cannot be run using implementations of Python 3. For that reason, Python 2.x continues to be widely used. The first time we use features of Python 3 that differ from Python 2, we point out how the same thing could be accomplished in Python 2. All of the examples in this book are available online in both Python 3.5 and Python 2.7. Okay, so we're going to use Python 3 in this course, but they're going to talk about the differences between Python 3 and Python 2 as we go, and the examples that we'll go through in the book are available online on the MIT site in both Python 3.5 and Python 2.7. Okay, chapters 12 to 13 provide an introduction to optimization, an important topic not usually covered in introductory courses. So optimization being the process of modifying a software, the software system, to make it perform more efficiently, typically in terms of things like speed, resource usage, or power consumption. You want to make a program the best it can be for a specific purpose. Chapters 14 to 16 provide an introduction to stochastic programs, another important topic not usually covered in introductory courses. Exactly. We're going to be getting this full, broad overview, which is great. So stochastic meaning randomly determined, having a random probability distribution or pattern that you can analyze statistically, but you can't predict precisely. Our experience at MIT is that we can cover either chapters 12 to 13 or chapters 15 to 16, but not both in the one semester introductory course. Yeah, so what they're saying is if for more advanced students, they might choose to where the first semester would be chapters 1 to 11, and then you could also add in chapters 12 to 13 or chapters 15 to 16, but doing both would be too much. But this playlist, we're not limited by semesters. We're just gonna go through the entire textbook in this playlist. Chapters 15 to 24 are designed to provide a self-contained introduction to using computation to help understand data. They assume no knowledge of mathematics beyond high school algebra, but do assume that the reader is comfortable with rigorous thinking and is not intimidated by mathematical concepts. This part of the book is devoted to topics not found in most introductory texts: data visualization, probabilistic and statistical thinking, and machine learning. Okay, so yeah, the second part is, as we talked about, is more about data science, using computation to help understand data. We believe that this is a far more relevant body of material for most students than what is typically covered in the second computer science course. Yes, in particular as non-computer science majors, we don't want to, for part 2, we don't want to just have the second course in line as a computer science major. No, we'd rather this broad overview of the computer science, computation and programming. So we can then, after this, go straight into courses dedicated to learning programming languages. We chose not to include problems at the end of chapters. Instead, we inserted finger exercises at opportune points within the chapters. Some are quite short and are intended to allow readers to confirm that they understand the material they just read. Some are a bit more challenging and are suitable for exam questions, and others are challenging enough to be useful as homework assignments. The book has 3 pervasive themes: systematic problem solving, the power of abstraction, and computation as a way of thinking about the world. When you have finished this book, you should have learned a language, Python, for expressing computations, learned a systematic approach to organizing, writing, and debugging medium-sized programs, developed an informal understanding of computational complexity, developed some insight into the process of moving from an ambiguous problem statement to a computational formulation of a method for solving the problem, learned a useful set of algorithmic and problem reduction techniques, learned how to use randomness and simulations to shed light on problems that don't easily succumb to closed-form solutions, and learned how to use computational tools, including simple statistical visualization and machine learning tools, to model and understand data. Okay? Programming is an intrinsically difficult activity. Just as there is no royal road to geometry, there is no royal road to programming. If you really want to learn the material, reading the book will not be enough. At the very least, you should try running some of the code in the book. Various versions of the courses from which the book has been derived have been available on MIT's OpenCourseWare website since 2008. The site includes video recordings of lectures and a complete set of problem sets and exams. Since the fall of 2012, EDX and MITx have offered online courses that cover much of the material in this book. We strongly recommend that you do the problem sets associated with one of the OpenCourseWare or EDX offerings. So yes, I'm going to post links in the description to the 2 courses that we're going to be following along with on the MIT OpenCourseWare site. We're going to go through all the exam problems. We'll use Python as we go. We'll be running code and not rushing through the textbook, through the practice problems, through the course. We want to really take advantage of everything this textbook has to offer.